And good afternoon from the Netherlands, here in Naarden, close to Huizen, where our organization is located. Thank you, Catherine and Alberto, also for the presentation. I think I have a lot of commonalities. I heard a lot of commonalities in the story that I will be telling, which is basically a trip down memory lane, how we introduced, or at least attempted to introduce, model-based system engineering in our organization. And failed to do so. But in hindsight, we could learn a lot of lessons from that first attempt. I also heard Catherine saying you won't succeed in the first go. Well, that's a painful lesson that we also learned. And we turned those lessons into, another way of working that did introduce model-based system engineering. So let's get started. Let me first introduce our organization. We are a member of the Thales group as our site Thales Huizen, working on secure information and communication systems. In that one site, in that one building, we do the sales, the engineering, and the manufacturing of a line of communication products. And in particular, the SOTAS product family is what I will be talking about this afternoon. If you look at SOTAS as a product family, we provide a set of capabilities. First of all, the primary capability is voice communication between the users of the system, so a local communication, but also provide voice communication connectivity to, for example, a voice over IP infrastructure. In addition to that, the SOTAS family also provides networking support, Ethernet switching, IP routing, IP services, and application hosting capability, so providing a processing environment, which includes a remote desktop type of application control. And like I said, it's a product family. It's a family of modular building blocks that together allow you to build a solution. And then that solution can be configured and scaled for all types of use cases, all types of platforms. It's typically deployed in armored vehicles, so it's in the defense industry, but it's also used in civil environments. Most particularly, it's designed to withstand the harsh and challenging conditions of being present in military vehicles. And our topic primarily is embedded hardware and software development. So that's the focus of what we are doing at Thales Huizen. When I say we, I am talking about primarily the engineering department, which is about 60 FTEs. 60 persons working on, the obvious disciplines: system engineering, requirements engineering, system architects, hardware engineering, software engineering, and of course, system test and integration. And we do that in close cooperation with our customer teams, who are in charge of defining and designing the customer solution based on the building blocks of the SOTAS product family that I just showed. If I go back in time quite a bit, we're going to look at our first attempt at introducing model-based system engineering and the lesson we have learned by doing so. It's about 12 years ago. We were launching a new revision of the SOTAS product family, and it was a successor of the earlier SOTAS product, but we used updated or new technology to do so. But at least it was a significant development effort which was kicking off. We learned from within the Thales organization about Arcadia and model-based system engineering. Heard a lot of good stories about it and how it would help us to be more efficient and effective. So we said, oh, let's jump in, let's do that. We got enthusiastic. So the system engineers and the lead architects all took the Arcadia and Capella training, and we started happily using models to help do our, initially our requirements engineering, but also our architecting job. But disappointingly, it didn't help us to be more effective and efficient. We continued to do the development as we were used to. Time passed, and about 2 years ago, another major development effort was about to start for the same SOTAS product family. And that was the time when we really looked back and contemplated on, okay, why didn't that model-based system engineering approach help us earlier? We were very enthusiastic about it. What did we do wrong? So In hindsight, there were a couple of pitfalls that we stepped into. First of all, we had individuals working on models on their own and just have the stakeholders review them, but there was no, let's say, commonality between the models. I also heard Catharina about this. We did not know when to stop modeling. We had a lot of implementation, realization detail in our heads when we started modeling, and we spent a lot of time putting those details in our models as well. We also used separate models for different aspects, which as such is not particularly wrong, but if you forget about the commonality and the relationship between those models, yeah, you don't speak a common language. So we also said, well, let's skip the operational analysis. We know what the customer needs because we already have an existing product line. So let's just jump in the system analysis and the logical and physical architecture. But that really wasn't a good idea because we forgot about why are we really providing the capabilities that we are providing. So what is the real need there? We thought we had a common understanding, but apparently we didn't, as we learned the bad way. We also, and like I said, it was 12 years ago, primarily used a waterfall engineering approach. And that implied that every model that we created had to be complete and correct at sort of the first iteration, the first attempt, which made it a hard job to do. And we also didn't really think about what we would do with the models that we created. So what are we going to do with the diagrams that we created? How are we going to use them in our existing engineering framework? So we ended up continuing writing text-based requirements documents after all. But basically, it comes down to the simple fact that we didn't really have a plan. But it's also my understanding, or the lesson that I learned, that modeling is not really about modeling, it's about the people. It isn't model-based system engineering that defines the right product for the customers. It is not model-based system engineering that defines the good architectures. Or make sure that we develop the right product, or make sure that we develop the right product in the right way. It's the people who do all of that. So forgetting about the people, that was also one of the mistakes we made. Because the people, we don't do it on our own, we do it together. We have big products, we have a large team. Actually, we have multiple teams with multiple disciplines working together. How can we make sure that they create the right product? Also in light of the fact that the complexity of the product is increasing in other disciplines. If you look at, for example, cybersecurity aspects or safety aspects, also playing an important role in defining and engineering your product, implies that you get more and more brains involved. And how do you get those brains aligned and make sure that they work effectively and efficiently together? Well, the idea is to create a common language and a common understanding, and use model-based system engineering as a means to achieve that. So I guess it all comes down to the most important lesson that we learned. That is, modeling is not really about the model. Modeling is about getting a common understanding. We also learned that modeling is a team job, because by working on a model as a team you obtain a better understanding. So we had to ensure that working on our models is integrated into our daily working process. And we realized that modeling is a continuous job. If you are working on the product today, we gain insights, and that will help us to improve the model tomorrow. And accepting the fact that modeling is a continuous job also helps you to stop, in the sense that if your model is good enough to achieve today's goal, then you're done for today, and realize that you can always improve or extend the model tomorrow. And of course, like I said, we had to make sure that we share the output of our modeling. Our modeling gives us a common understanding, and that understanding is to be shared in the organization. So we had to define how the result of modeling is shared by using diagrams in our documents, but how and which one, or by exporting the models themselves, by defining which part of the model is shared and how is it shared. And again, I see a lot of resemblance with the earlier talk by Catherine and Alberto. But it basically comes down to this nice quote from Mr. George Box. And I really like this quote. I really like this picture, not only because he resembles my grandfather, but he pinpoints the fact that all models are wrong, but some are useful. It's not about the model at all. It's about the people, getting the people together and getting that common understanding, making sure that they have they are aligned. So we had the opportunity to 2 years ago start anew, and based on the lessons that we, based on the contemplation, have learned, reconsidered our way of working. So how can we be effective and efficient in our product line engineering? And I would like to emphasize that product line engineering aspect, I will get back to that later as well, but it's not really one product, but it's a line of product that we are talking about. And that is what we are trying to get an efficient and effective way of working for. So we started off by simply defining our vision. It's also a bit reflected by this nice looking into the distance picture. We came up with what we call the SOTAS engineering vision. And that vision is that we want to achieve that we share a common language that we use to create a common understanding of what SOTAS provides, why it does provide so, and how that is realized. And that common understanding is also continuously updated, that it is easily accessible, and that it's used throughout the organization. That is what we had in mind, that what we like to achieve. And we also set the objectives for our engineering way of working. First of all, to create that common understanding of the SOTAS product family, but also efficiently address the variability and commonality between the products. So it's a product line. It's a line of products where we have multiple variants of a product that must comply to the same or to similar requirements. And also multiple variants of the product that can be built or must be built using common components. That is what we would like to facilitate. In doing so, support the jobs of the stakeholders involved. Primarily the customer team and the system engineering team, but our main customers are the hardware and software teams, and of course the system test and integration team are also very much interested in that common understanding. So those are the people targeted for these objectives. And we also said, let's use modeling. Well, we already agreed on that, but why use modeling? Like in the introduction, Stefan already said, I've experienced that myself in software architecture, how much modeling helps you. It helps you to express ourselves or yourself in more than just words. It helps you to be consistent in the way you present your information. It helps you to identify what you may have overlooked, and it helps you to share knowledge and transfer. So maybe I'm exaggerating a little bit with this love you picture here, but the love for modeling still was strong, so it had to be part of that new engineering process. But the same applies for the love for Arcadia. I really like the way that Arcadia helps you clearly separate various layers of concerns, where in the operational analysis, the primary question to ask is, what are our customers trying to achieve? And what I really like about the Arcadia methodology is the fact that there's no such thing as a system entity in the operational analysis. And that is for a reason. I mean, you shouldn't be thinking about the boundaries of your system yet. That is part of the system analysis responsibility. So understanding what the customer needs are, and then translate that to what the capabilities of our products are to help them achieve their goals. That is the importance, of course, of the system analysis layer. And then the logical architecture, at least at top level, will help us define what our products need to do to facilitate those capabilities. And then in the physical architecture, we'll look at the more detailed how we realize that behavior. And also really love the fact that when you are working on a particular layer, it doesn't really matter if you start at the physical architecture or at the operational analysis layer. As long as you ask the why and the what questions, you can easily navigate through these layers. If you are familiar with the realization, you can ask yourself, okay, but why did we realize this? What are the logical functions that we are realizing here? And the same goes for those logical functions in the logical architecture layer. Why did we introduce those logical functions? Well, because they help realize a capability that we have defined helps our customer. So asking yourselves the what and the why questions really helps to assist the consistency and completeness, but also making sure that you are not dealing with the wrong aspect in the wrong layer. Anyway, enough of the love affection. On to putting MBSE into the practice. The first thing that we did was to come up with what we call the SOTAS engineering framework, which is a hierarchy of models, where each of those layers in that hierarchy have a particular objective. I'll get back to these layers in more detail. Looking at the solution model, the primary objective of that model is, well, first of all, to define our common language, common terminology, to define a product line reference solution architecture, and to come up with a set of conceptual products that help provide the capability that we want SOTAS to provide. But they are not really concerned about how to realize those products. That is up to the product architecture models. So there we have the scope of a product defined. And the problem at hand there is to decompose the product into hardware and software components and put an emphasis on the role and responsibility of those components. Not really design the hardware or software in detail yet, because that is up to the component model. To be honest, in the hardware discipline, we don't use the Capella modeling, but we do in software as well, and use that to decompose a software component also into software modules, where we put, again, the emphasis on the role and the responsibility of that module, and not so much the realization, the software design of that module. So, talking over the various layers of the SOTAS engineering framework, at the top, like I said, the solution model. Once again, the overall objective there is to define our common understanding, our common language, and, well, basically support defining the family of products, and do so efficiently, making sure that we can reuse product requirements. And we do so by, at the operational analysis level, well, obviously define the operational need of the customer. What are the problems they face? What do they try to accomplish? And translate that into, okay, and because they face these problems, this is what our product or product family will contribute or help them with. So the system analysis focus on the scope of the SOTAS solution and defining the interaction of the SOTAS solution with its actors. The next layer is the logical architecture layer, and just a little bit of focus. I see a lot of similarity again with the previous presentation. You might recognize the door database, doors interface at the back here as well. What we do is, at the logical architecture, we decompose the solution into components where we define logical functions for those components, allocate them to them. And for each of those logical functions, we specify that function in more detail in the requirements database. So the requirement database is used to capture, let's say, a superset of all possible product requirements. And actually, a section in the doors database has a one-to-one relation with the logical function in our model, in our solution model. At the physical architecture layer of this solution model, we primarily do the allocation of those logical functions to physical components that are part of conceptual products. So, for example, in our system where we have a user interface unit, the unit that is closest to the user provides the user interface, obviously. It might host an analog audio device interface to provide the audio interfacing, but it might also host an application hosting client, so an interface for a screen and an input device or input devices. Well, those are the variabilities for a range of products, and yeah, you can also say that we defined in our solution model a superset user interface unit. And well, like it's illustrated here, for example, the application hosting client is then allocated to that conceptual unit. But then we end up with a set of conceptual products, and we are not making conceptual products, we're making real products. So this is where a non-Capella model comes in, a feature model, where we have what we call product variant definition. And the feature model, we built a feature model that is based on the components and the functions from Capella. So a component from the solution model corresponds with a feature in the feature model. And to define a product variant, simply we can use, we can activate or deactivate a feature in the feature model. And in doing so, we basically inherit a set of requirements, the associated requirements that are in the DOORS database for that feature. When it comes down to sharing information, and again, a lot of similarity with the previous talk, we also use documents. Well, first of all, because we, as a company, are used to doing so, but also because it's easily accessible for all stakeholders. It implies that the stakeholders don't have to have Capella tooling knowledge to be able to, use Capella as a means to access the information. And also, we thought about exporting the model into, let's say, HTML, but then again, you don't tell a story, and the ability to guide the reader through the model, to really tell the story, to really share your knowledge, a document helps you to achieve that. But we use multiple sources to generate those documents, and actually we generate documents at 2 levels from that solution model. First of all, basically to define the product line reference architecture, we have architecture description documents. They're primarily based on the Capella diagrams and the descriptions, which are, by the way, also part of the Capella. So there we do the description of the model in the Capella tooling. But those same diagrams or other maybe different representations with the same entities are used in the product variant specification documents, where we also include the requirements, the superset of requirements in the database featured by the attributes in the feature model, and put them into one specific document for each product variant that we have. Going one layer deeper in the product models, the objective of the product models is primarily to decompose a product into the hardware and software components. So what are the hardware boards that are used to build up this product? What type of platform software, like operating software, is going to be used? What are the software applications on this unit? And once again, the commonality aspect is addressed here. Hardware and software components may be specific to the product or can be generic. So the components may be used in multiple products or multiple variants of the product. Primarily objective of this model is to define the role and the responsibility of each of the hardware and software components, and not so much to the actual detailed design of those. And of course, to identify the interfaces between the components. And similarly to what we do with the solution model, we use the product model also to generate product design documentation. At the lowest level of the hierarchy, we have the software component models, where we decompose the software components into software modules. So like libraries, executables, whatever you. And once again, they may be specific to a particular software component, a particular software application, or maybe shared between applications, shared between components. And again, the emphasis here is on the role and responsibility of each of the software modules, and not so much the detailed design of the software. And again, identify the interfaces between the software modules. And I'm going to repeat myself. At this layer also, we use the Capella model to generate the software component design documentation. So putting that all together, if you look at the SOTAS engineering framework, the revisited, the same diagram is shown before, but now augmented with the documentation and the feature model. Like I said, the solution model at the top basically provides the superset of all products by means of conceptual products. By using the feature model, we can filter those requirements, filter those aspects into product-specific specification documents, which are input to the product models, where the product models are used to generate the product design, and those are input to the various software components or even hardware components. And in case of the software components, we use again Capella models to model those components and generate a software component design document from that. We are part of the Thales organization, and Thales provides a tool suite which includes also a document generation tool for Capella. So it's not a standard tool. It's not M2Doc or whatever you like presented before. But we use that to also automate the document generation. And especially in the solution model, the diagrams from that model are used in lots of product-specific specification documents. So by having a nightly generation of documentation, we don't have to bother too much about updating all the documents ourselves. That process is being automated. And also all those documents are in a location stored where it's available and accessible and used throughout the organization. So maybe a little bit old-fashioned to have documents for that, but it serves our purpose, so fair enough. Another aspect that we organized is to facilitate that teams work on the models together. And we have, teams in the hierarchy of our organization, which is more or less aligned with the hierarchy of the models. At the top level, we have the solution engineering team. Those are the ones are in first contact with the customer teams, work out and assess the need of the customer, and translate that into the set of capabilities that the SOTAS product line family should provide. But we do that in close cooperation with the product architects. So product architects are also part of some of the solution engineering team activities. At product engineering team level, where we work on the product models, we have the solution engineering team members, a representation of that also involved. So once again, it's a collaboration between the multiple disciplines working on that model, also to ease the transfer of knowledge. And we also do that in close cooperation with the hardware and software architects working on the hardware and software components. And similarly, at the bottom, we have if it comes down to the Capella models, the software teams, but also in light of hardware engineering and the product engineering teams are also working together closely to make sure that we have really that common understanding. And we also facilitate this way of working by having a continuous process in place where we integrated working on those models in our weekly schedule. So we have weekly working sessions to discuss and refine the models and to do that in close cooperation. Where the rest of the week, of course, we have all the time to work out the details and come up with a new revision of it. And like I said on the previous slide, the transfer of knowledge between the teams, it's the cooperation in our organization of, let's say, 60 engineers. It can easily be achieved by working together closely rather than passing on documents to each other. And what I didn't put up here, but one of the principles that we work by is to agree first, document later. So first in a common working session, we agree on, for example, the specification or the architecture, the ideas. We exchange ideas about that, and then establish that and document it before we we don't want to get into the I prepare something offline and you have to review that type of cooperation. So yeah, getting back to what we did to introduce model-based system engineering into our organization. Well, first of all, we planned our model-based system engineering. So we defined what we want to achieve with modeling and defined the hierarchy. Which models do we want to have and how do they relate and what is their scope, what is their objective? And to be honest, it's not something that we did upfront completely and don't change. Also, making a plan and do the planning is an evolving process, so to say. But of course, it's good to have a mark on the horizon and putting a vision up there and say, okay, this is the way we think we should go forward and agree on that as well. Second thing that we did was to organize working together, build the models together, build that common understanding. Don't do it behind your desk. Use and improve the models in joint working session, making sure that the relevant stakeholders participate. And lastly, but not the least, embed sharing the modeling artifacts. So make sure how are you going to use whatever you have created in your model. How are you going to share that? How are you going to use that in the rest of your engineering process? So use the model to generate the specification and design documentation as the primary source for the specification and design documentation, and have that documentation easily available as well. And on that last remark, thank you for your attention. And maybe there are questions that I can help answer.
Yes, thank you very much, Erik, for a very detailed and an insightful presentation. There are a few questions, and we do have times for a few questions indeed. Just as a reminder for the audience, you can ask your questions to Erik in the Q&A window, and you can also upvote for some of them. So let's look at the first question. Did you identify a dedicated role within the organization to stick to your initial plan? It's a bit of a cultural change.
I'm not really sure what is meant with a dedicated role.
What there's, I guess it's was there someone to make sure that people were actually following the plan. So I guess we're actually doing some work on the models, working with the models, these type of things, I guess. Making sure that the plan is adopted, I guess, and managing the cultural change.
The initial team, let's say, to work on modeling or to start using modeling was the solution engineering team at the top. And although if I present it in this fashion, it sounds like the plan was already well fully detailed as I just presented it. That was not the case 2 years ago. So when we started off doing the modeling, we basically as a solution engineering team, top level team, were a team of 5 system engineers, architects working on it. So and we, having been involved in the SOTAS development for quite some while, and also had the initial, or some of us had the initial experience of Arcadia and Capella, and saw the benefit of it. We basically, well, we did do the SOTAS engineering framework, setting the objectives, but we really didn't have, let's say, a detailed plan on, okay, what type of diagrams will we be using and how will we use those. So that is basically part of the evolving plan, if you want to put it like that. And maybe, well, my official role in the team is modeling champion. So monitoring. I don't consider myself a champion, so I have a hard time calling it that way. But anyway, a modeling champion as being the one taking this into account, so making sure that we do it consistently. Not really sure that I fully answered the question.
Yeah, thank you, Erik. Let's have a look at this one. If you're maintaining a feature model with another tool, why you switch to Capella to do the further development? What are the benefits of Capella over the other modeling tool?
Well, it's not really another tool in the sense that you could consider the feature model as being a filter that you can apply on the Capella model or on the requirements in this case. And like I said, we are part of the Thales organization where the tool suite introduced or contains pure variants, which is the feature modeling tool that we use. I also heard that in the previous presentation, by the way. But those two tools have been integrated already in our tool suite. So yeah, where the Capella tool is primarily based on modeling your solution, the feature model is primarily based on modeling your commonality and variability.
Thank you. Next question: is the electronics hardware team using Capella, and if yes, what for?
If it comes down to once again the hierarchy of models at the bottom layer for hardware components themselves, we don't use Capella. You could argue that the product models also are, let's say, the high-level design for the hardware. For example, if you design a unit that consists of a motherboard and some interface modules on that decomposition is the level of decomposition that we do in Capella. So those hardware aspects are definitely being used being modeled in Capella. Yeah, then the interface is also between the hardware elements, so the hardware boards is also being modeled in Capella, but to the extent that it is clear that what type of interfaces do we want to provide and what type of information goes back and forth. So basically, what type of functional exchanges do we want to support, and not so much the nitty-gritty details of what is the meaning of a bit, for example.
Okay, another question more on the hierarchy of models that you have. Is there a certain rule for separating products from components in terms of complexity or abstraction level, and how to clusterize and treat interfaces between different teams working on different components or products on the same model?
I'm trying to understand the question.
Yeah, so the first part of the question is, I guess, where do you start and when do you stop when putting information at the product level or component level in your hierarchy of models? And I guess the other question is more about, then you have different component models and product models. How do you make sure that you have different teams working on those different models and that they stay coherent, and how do you manage the interfaces between them?
Yeah. At the top level model, the primary objective of the model is simply to address or identify the contribution of a certain product to the capability that SOTAS provides. So the idea behind that is that a product, let's take the user interface unit as an example. The functionality that we expect from a user interface unit should stay the same or more or less the same, unless you provide, of course, more capabilities, regardless how you implement that. So, for example, if you implement an audio interface as part of a motherboard, or you implement an audio interface as part of a audio interface module, that is not really an aspect that is being addressed at the top level. At the top level, we stick to, let's say, the product as a black box. But in order to define, okay, what are the functions that you can assign to such a black box clearly, we come up with the concept of components there. At the product level, models, there you do the more detailed realization architecture, but you could argue that it is the system engineering aspect at product level rather than at solution level. I think what also helps the fact that we are not a very huge company, in the sense that we have, yes, we do have 60 people, but it's only 60 people. So, and we are not located far from each other. We are in one site. So also let's say the informal communication is just as important as the formal communication here. And in striving to get an agile way of working, and also to have each and every engineer contribute in the design and architecture process, we don't want to put too much implementation or realization detail into our models too early. So yeah, you could say that even the product models are fairly abstract.
Okay, thank you, Erik. Completely different question. Is it possible to do a reliability analysis in Capella?
It's a very good question that I don't think I can can answer. We don't do any reliability analysis in our Capella models. So.
Okay. Okay, this one I'm not too sure if I understand the scope of it, but how to perform bidirectional traceability in Capella?
The traceability that we provide is basically the traceability between the component names. So terminology and that common language is key here. At the realization level, I might implement let's say an HTTPS API interface for a particular reason. But the fact that it's HTTPS and API is not really into the terminology. We just say we provide an application interface or an application gateway interface. So that common name, that common terminology is what binds all the, let's say, the solution model, the product model, and the component model together. And as a matter of fact, that is one of the one things that we gained from introducing Capella 2012, 12 years ago, or 2011 it was, 12 years ago, that some of the naming conventions that we introduced there, we have managed to maintain them through all the levels of detailing the engineering. So in our software architecture or software modules even, the same terminology is being used as is defined at that top model. And I really think that also, well, magically gives you the traceability.
Okay. Is the model used just among system engineering professionals, or are also for transfer of information between detailed designers?
It's also used between system engineers and, let's say, hardware and software architects. If I elaborate a little bit on our organization, we have the solution engineering team doing, let's say, the top level system engineering, but they are talking with the discipline architects, so hardware architects and software architects, also getting involved there in, okay, what are the possibilities and with respect to allocating requirements or functionality to products, and even in the terminology and the common language that we use, we transfer that to the hardware and software scrum teams that we have, who are working on the detailed design of hardware and software. And as a matter of fact, one of the nice anecdotes, as being an architect for SOTAS for so long, I also have the honor to do the introduction presentation to new employees, new engineers working on our department. And nowadays, that is quite an easy job, because all I have to do is just walk them through the architecture design documents that we have, and introduce them to the terminology that is elaborated or explained there. Whereas in the old days, I had to do the presentation myself and copy that from here and there. So, yeah, transferring that information throughout the organization is one of the objectives that we have. We would like everybody to speak the same language.
And maybe a final related questions. How do you find the best to train the team in the use of Capella? Formal training sessions, coaching, mentors?
I think the answer would be a combination of the above, but I would definitely, I quote Catherine again, not in the first go. Don't expect this to work in the first go. And know what you are doing, know what your goal for modeling is. Those are fairly important. Yes, it is good to have the formal training, because without the formal training, you're basically lost. Capella is quite an extensive tool. It's a very professional tool that really helps you. But if you don't know what you want to achieve, then even that nice tool cannot help you. So I would really say take the formal training. Just go through the exercises, do that. And then trial and error with coaching and mentors. I think that would work best. But don't perceive it as I do this the first time right job and I can finish it and then it will be done. Consider it a continuous job. That would be my recommendation. That's at least what we have learned. Especially what I talked about earlier, you can be happy with what you did today if it serves today's goal. It doesn't have to be perfect. I'm quoting Mr. Box again. All models are wrong. Some are useful. It's the fact that it is useful that you should aim for.
Thank you very much, Erik. Bye.
Bye.